Hello, welcome everybody back to vBrownBag. We are continuing our series on the Certified Kubernetes Administrator exam today. This is part 2 of the networking series with Marino, Wijay. For those of you who may need a refresher, this is the course schedule, or I guess I should say show schedule. If you were tuning in last week, you might notice that, hey, are we going backwards? Because last week was episode 7. Yeah, we're recording them a bit out of order, but don't worry. If you're watching this on YouTube, it's going to be put into a playlist where they're in order. And if you feel like you want to watch these in order, just, stop watching them live and watch them when they're on YouTube, I guess. But hey, it's the same content. It's good either way. After this, we will be continuing with just a couple last episodes. Next week, we're going to actually do, I think it might be episode 9 with the US show, but we'll be doing episode 8 with the EMEA show. We kind of have split this up a bit. Basically, we're going international. So if you didn't know, we have multiple shows in multiple time zones. You see some information here on the Twitter handles, the hashtags, also how you can sign up to be a part of the various shows in different regions of the world and even different languages. So go ahead and check that out. If you really want to be a viewer for the next episode that takes place on the EMEA show, that's, if you're in the US, it's like the middle of the day. You can watch it on your lunch break. So yeah, you can head over to vbrownbag.com/brownbag so you can sign up to be reminded when this podcast starts recording. If you're watching this live, hopefully you already know that we have a YouTube channel. You can go check that out, youtube.com/vbrownbag. If you're watching this on YouTube after the fact, thank you for joining. Check out all the other videos we have on our channel on multiple topics besides Kubernetes. We do VMware, we do AWS, we do Azure, you name it. And then head on over to vbrownbag.com and sign up to be reminded when we're recording on a weekly basis. My name is Ken Nevlin. I'm your host today, but I am not the star of the show. That would be our guest. That would be you, Marino. Welcome.
Thank you so much, Ken. And thank you for having me back here again to cover off part 2.
My pleasure.
Let me go ahead and share my screen. And I just want to say hello and good evening to everyone here. Thank you all for coming. Let me go ahead and share my screen here. Can you see that, Ken?
Yeah, I sure do.
Awesome. Okay. All right. So we're going to dig right into it. In the last session, what I ended up covering was a lot of the more core fundamentals of Kubernetes networking, especially when it comes to how to set up the infrastructure or what that means for you if you're playing in a lab, as well as some of the core Kubernetes networking primitives and objects that you would interact with on the exam itself. I'll review some of that very quickly and briefly. But for those that weren't on the call last week, or sorry, 2 weeks ago, my name is Marino Wijay. I am currently unemployed. I actually was working at VMware up until October 15th. I resigned to take on a new opportunity at a startup. And that startup, I start November 1st, but I'll actually officially announce it and the name of the startup very soon. But I will be a field engineer and I'll be working with some very cool cloud native networking technologies. So I have a lot of, I guess, experience in the realms of data center, storage, operations, networking, and Kubernetes. And so it all kind of just comes together in both my new role and anything I do going forward. Some of the stuff I've seen over the last, I guess, 15, 16 years has pretty much come full circle. Things have changed, things do look different, but fundamentally things are pretty much the same in what we're after in terms of outputs and results. You see my likes there. If you want to follow me on Twitter, feel free to. And if you want to connect with me on LinkedIn, you're more than welcome to. All right, so for the agenda, we're going to briefly look at the blueprint specifically on the networking side. The last time I covered it, I covered the entire blueprint. I do not want to do that. I'm sure others have in several sessions. And then I'm just going to briefly review some of the things around services networking. So in the last session, what I did was I actually went through a hands-on approach of services. So I showed you how the services work inside of a cluster. This time, I just want to provide a more theoretical overview of it so that you have a better understanding of it, and you have some notes that you can take back with you. So I'll find a way to make this presentation available. It actually has the previous session in addition to this session, both in one deck. So we'll figure out a way to get it out to y'all. I'll also just briefly cover off CNIs and what they're used for. And then we'll shift our focus to CoreDNS. There are a few things that I feel that it's worthwhile all of you should know and should be aware of. And there is one quick question. Okay. And yeah, so I'll cover off CoreDNS and what it's used for in the context of Kubernetes. And then I'll cover off Ingress, which is actually a pretty important topic. And it can be kind of confusing because you look at things like services and then you wonder, how does that interact with Ingress and Ingress capabilities inside of a cluster? So let's just jump right into the blueprint and right into services and networking. So for the exam, services and networking make up 20%. That's like 1/5 of your exam. That's a huge chunk. In fact, I think in the previous iteration, it was maybe 12 to 15%. And this is a heavier chunk, but I can understand why, because they really want you to treat Kubernetes as a distributed system, but behind that distributed system is networking. And so networking is a very critical component to how Kubernetes will operate and how the different components interact. So in that domain, you're going to need to know and understand host networking. So how do nodes inside of a Kubernetes cluster communicate with each other? You'll probably need to go and review things like ports and the different ports that are used for the different endpoints and the different pieces inside of a cluster that do communicate. There's another area where you're going to need to understand the connectivity between pods. How do they communicate with each other? Do they even talk to each other directly? And what is required behind that? Then there's the element of services networking. So how do we expose applications so that other applications or external end users or other external applications can access those that reside on the cluster? And we do so by exposing it using a cluster IP service or a node port service or a load balancer. Cover this in a little bit more detail as we go along. Then we're going to go dig into, well, then you have to worry about Ingress controllers and Ingress resources. One thing about the exam that I took, and without breaking any sort of NDAs, I can say safely that you're not going to have to go out of your way to build out an Ingress controller on the exam. It actually is quite time consuming. But what I would recommend is you familiarize yourself with how to do so, just so that you understand the different components that are required for the Ingress controller. One thing to be aware of is that there's always going to be something that's providing that Ingress controller capability. And that something is not native inside of Kubernetes. It's actually an external component. And I'll talk a little bit more about that. The Ingress resource itself is basically the definition. So we'll talk about what that means in terms of how to get to your backend paths. Ingress really translates to backend routing. We'll also talk about CoreDNS because CoreDNS is important to the exam. So for example, if you can't resolve the names inside of your cluster for like accessing a particular service, it could be because CoreDNS is not functional, or for a variety of reasons, maybe it's not resolving addresses as you expect it to. And then the last one, the last topic on that domain is about CNI. So really, I don't think you're going to be expected to know the ins and outs of every single CNI. There are too many to be aware of. It's more a matter of knowing how to install one and ensure that it's functioning, ensure that it's present so that something like CoreDNS would function. And I'll talk about that because it's important, especially when you're, let's say, running kubeADM to bootstrap a cluster. Okay, so let's talk about services, because if we just go back to the agenda here, I mentioned we're going to review services, and there are three types that we really care about. There's the cluster IP service, there's the node port service, and then there's the load balancer service. So in a nutshell, I'm not going to read this all out to you, but the cluster IP service is meant to expose applications internally to other resources inside of a cluster. So maybe you've deployed a database as a set of containers, but there is no reason to expose that database outside of the cluster. you have an application, however, that does need access to that database. And what you just want to be able to do is take advantage of the primitives and capabilities of Kubernetes. So you would apply a service. Now, to make sure that that service that front ends those databases or those database pods is not exposed externally, you're going to have to use a cluster IP. Now, there are other situations where you will use cluster IP. And in fact, I'll show you inside of like a working Kubernetes cluster. For example, CoreDNS is exposed only using cluster IP because there are services only within the cluster that need to access CoreDNS services to be able to resolve various other things inside of the cluster. Now, in terms of creating a cluster IP service, you have a number of ways to do so. You can easily run an imperative command, the kubectl expose command. So you're either targeting a pod and the name of the pod or a particular deployment. But one thing you need to be aware of is that in the imperative approach, you're actually going to specify a flag here. If you don't specify a flag, it'll all automatically default to cluster IP, and you can go back in and edit it and change it to something else. But just to be a little bit more specific, you can specify the type as cluster IP. Now, you also want to go in and specify the port and the target port. Now, these come into relation with, or actually have relation to the port on the pod and the port on the proxy that is going to be proxying for this actual connection to the pod. And so I'll draw that out in a diagram so you understand it better. So in this diagram, right, this is the cluster IP service. So I have a client here and I'm trying to access a service, but I can't because I don't expose the function of this pod in any way, shape, or form. Now we look at it from the perspective of a pod, right? I have this pod right here, and this pod has a port or a target port of 8080. Okay, so if I'm going to access this pod right here internally, I would access it on port 8080. But I've also set up a translation to say if any connection is coming in to that kube proxy, it's going to access it on port 80. So what actually is going to happen is any sort of communication that occurs towards this pod is going to be towards the service on port 80. So the service actually presents an IP. There's actually an IP that's assigned, and you access that IP and the port itself, and then that'll give you access to the pod. But the primary reason we do this is because if for whatever reason this particular pod vanished, well, what we need is another pod to come back and service the same function of that original pod. And so when we do that, when we actually swap in that new pod, when we deploy or schedule a new pod, it still is going to be backed by the same service. So any other, let's say, service inside of the cluster accessing this pod or the application behind this pod can continue to do so because nothing has fundamentally changed in the way it's being accessed. We're still using the same port. We're still using the same IP. The only time this changes is if I delete the service object. Now, the majority of the time, you're not really going to be creating cluster IP objects for the sake of the exam. Maybe you might here or there. In the real world, you might for a variety of different applications. And I recommend you go take a look at some of the Kubernetes documentation tasks, which call out some of those use cases as well. The next type of service is the node port service. So I have a little bit more information here, and this is primarily because this is important to understand if you are working in an environment where you don't have a load balancer and you have a single node Kubernetes cluster. So let's say this is your lab environment. You don't have access to let's say a cloud load balancer or a local load balancer. So the way to be able to expose your application is using the node port service. So what the node port service is doing is it's actually playing on the cluster IP. So if we actually look at this one line here, right, and I'll actually show you in the form of a diagram in a second or in a few minutes actually, we still have this target port, right? So this is the pod and its IP address, and this is the port that we would access that pod on internally. Now we have the kube proxy IP assignment here and the pod that we're accessing it. But in addition to that, we also have one more translation. So you can think of this as a three-way translation, right? We have this one more translation here, which is the IP that I would use externally as a client to access this application. So I would obviously use a DNS name, like let's say website.com on port 30,080. But the moment I hit that port, that is actually going to take me through the kube proxy over to the actual pod itself. And so the pod, I mean, again, it could die and another one can come take its place, and I would still have the same access to the same application altogether. Now, one thing to note is, let's say you have a multi-node cluster in your environment. Even if you don't have a load balancer, you can still access your application on any one of those nodes that you have. So as long as you have the node's IP, you append the port to it, you can go ahead and access the pod or the application behind that pod. Now, in order to create the service, we take a very similar approach here, where we go ahead and we expose the pod or the deployment. And in this case, we're actually specifying the type of node port. Now, earlier I mentioned if you actually don't provide if you don't specify this flag right here, what ends up happening is it'll actually default to cluster IP. So this is why we want to go ahead and specify the flag of node port. And then we'll go ahead and specify the port as well as the target port for the pod, and then the node port that we want to access that application on. So this is something we can change. We can change this to anything we want. There's actually a given range. I don't recall it at the moment, but I'll go find it and see if I can share it with y'all. But the idea is there is a range that you have to stick to, and within that range, as long as you choose any available port, you can always access that application on that port. Now, to verify any sort of services that you create, you can just run the kubectl get services, or SVC for short, and then it'll spit out all the services in the specific namespace that you're in at the moment. Now, the view of the view of node port is a lot like this. So as I was saying, right, you've got this node right here. This is your worker node. This is your Kubernetes worker node. This could be one of your 3 nodes. This could be your mini kube node. This could be a single node in the cloud. It doesn't really matter. But it has an IP. It could have a private IP or a public IP. It doesn't matter. But it's going to be DNS translated to something. So when we want to come in and access that application, we'll go and hit that website.com on this port, and then we'll hit the service, which will translate it to the IP, or the internal IP, the service IP, on port 80, which would then translate it over to the actual pod's IP and the port that we're accessing the application on. So one thing that makes this all work is the selector here. So we don't have to go in and manually specify the selector or label or anything, because if you go back, if we go back here, right, the moment we go and expose the deployment in a pod, it'll automatically create a label and assign it to the deployment, or the deployment of the pod, so that the actual service will always watch and match. So whenever there's a request to be able to communicate with it, the service will look to see if there are any pods that have this label. If it does, well, there's the pod that can service that HTTP request or that inbound web request. Now, the one challenge with using node port services, if you have like 500 nodes in your cluster, you're not going to remember every one of those IPs. Not that you ever would have 500 nodes in your cluster, but as you scale your Kubernetes cluster, it just becomes highly impractical to be able to use every single IP to be able to access that, that application. And so this is where the load balancer service comes in. So the load balancer service is basically just that. You're actually using some load balancer. It could be anything. It could be the Google Cloud load balancer. It could be the NSXT load balancer. A little biased because I used to work for VMware. It could be the Abby load balancer. It could be HA proxy. It could even be your F5 load balancers if you've ever worked with that. And if you're using a lab environment, it could be Metal LB. But these are load balancers that are effectively doing one thing. They are balancing the load of the requests that are coming inbound. And so while it is a little more work to actually set up a load balancer manually, if you're using some sort of Kubernetes as a service engine like EKS or GKE for that matter, they're automatically attached to the load balancers in the native cloud providers or in the respective cloud native providers, because it makes it easy to call on the service, and then you'll automatically get a public IP in which you can go ahead and access your application. But what are we actually doing with this, right? So let's think of it this way. I've decided that I want to deploy my application to Sivo Cloud, right? And Sivo Cloud will offer me a very cost-efficient approach to running my, let's say, fancy WordPress app with high availability. Someone else is managing the infrastructure, but I still get access to the cluster. Now, I can use node port service, but I don't want to have to access that application on every single one of those IPs and then create a DNS record for all three of those IPs. Because if any of those nodes change, then I have to go back in and modify my DNS. So I'd rather use a front-ended load balancer to be able to handle a lot of these requests for me. So in the Sivo Cloud, if I spin up a Kubernetes cluster, a load balancer is ready to go provisioned so that when I call on it for the service type, it'll go out, provision me a public IP, and assign it to the service. So I'll show you this inside of the lab, so it'll make a lot more sense. But in a nutshell, this is what the actual topology would look like. So in the previous diagrams, I had one node. In this diagram, I have 3 nodes. And those 3 nodes are front-ended by that load balancer here in the essence of using it for the service type. So I didn't specifically spend time on the previous YAMLs, but I will on this one right now before I just dive a little bit deeper into the diagram here. So, we're following the same set of principles for having, your API version, the kind, metadata, and spec. But one thing we want to be aware of is the type here. The type is load balancer. So you can also imperatively create this. I'll show you how. And the reason why you want to imperatively create this is it's time saving. You can always create it, go in, edit the service live, and make changes as you need to, instead of having to create a YAML file and then have to mess with indentation. I recommend it for the sake of the exam because you have 2 hours and I think you have a good number of questions. So it would be in your best interest to use imperative commands. But for your understanding, right, in the YAML file, we'll specify the type. This field right here, cluster IP, is optional. You don't populate it. If you don't populate it, it'll auto-populate itself. And then down here, right, one thing to note is you don't actually specify anything here. When you actually get this, if you decide you want to, let's say, output the status of the load balancer service via a YAML file, it'll actually tell you the current status and the IP that was assigned to it. So let's just say if you removed it and you rewrote this YAML back into the service, it may reassign you a new IP. Now, that could be problematic if you're in production, obviously, you wouldn't want to do that. But if you're doing this in the lab, there's no harm in playing around with this stuff. Now, just going back over to this diagram over here, I've got the 3 nodes, like I said. I'm front-ending it with a load balancer. And what's interesting is that load balancer IP is one that's public. So it would get assigned the DNS record. So there'd be an A record and a PTR record in your public DNS server. And anytime someone tries to access this application or actually access any application on your cluster, they're going to come in through this website and specify whatever port and maybe even like a backend path. I'll talk about that. It's a little bit important when it comes to Ingress, but we'll talk about that shortly. So in what's going on here is I'll get translated into an IP, but this load balancer will then direct it according to whichever node has the least amount of load, or whichever is most available or whatever it is. And they'll be the ones to facilitate the response and translation down to the actual pod itself. So what's really important about this is, like I mentioned, if I lost a node or I lost 2 nodes, this IP right here, 5.4.3.10, does not change at all. That stays the same, and that still gets pinned to your DNS name. I'm going to stop here for a quick second. Are there any questions about services, about the cluster IP service, the load balancer service, or even the node port service?
I don't see any questions at this time.
Awesome. Awesome. All right. 6 more slides and we will move right into a lab environment where we're going to mess around with a few things. So I just want to briefly review something on CNIs. Now for the exam, what's really interesting is the exam itself obviously will expect you to deploy a CNI. It's difficult as it is to remember a lot of different things inside of Kubernetes, like how to do things, how to go in and imperatively create certain objects. So my recommendation is to go bookmark this link right here, because this link is actually a task which actually shows you how to create a high availability cluster with kubeadm. But what's very interesting about this one link here is that there's actually an example on how to deploy a CNI right here. So you can't save this right here. You cannot save this link. You cannot save this command right here, but you can bookmark this link and make it accessible to you during the exam so that you can refer back to this one command here to go and create your Weave CNI. Because the thing you have to be aware of is in the situation where you have to bootstrap a cluster, your cluster is not going to be ready until CoreDNS is ready. CoreDNS, it cannot be ready until your CNI has been deployed. And to be quite honest, you can scour the documentation. You're likely not going to find any sort of CNI example. So this is likely going to be your best bet. In fact, I almost feel like the people who wrote the exam and developed the exam intentionally, created this whole approach to making sure that you read documentation so you would catch something like this. So bookmark it, keep it for your reference, and you'd be good to go. Now, that being said, you don't have to use the Weave CNI. You're welcome to use something else. You're welcome to use a CNI that you might be more familiar with, or you're very comfortable with, like Cilium or Calico, or maybe even Antrea for that matter. A couple of other things I'll just point out is that if you're trying to find out some information about the CNI and what's deployed, you can check this directory right here. And if you want to find details about the CNI, you can go into this directory and cat out this one file. All right, CoreDNS. Okay, so this one's a very important one. So in the last session, I actually kind of glossed over CoreDNS and its importance. I mean, it's critically important because without it, you're not going to be able to look up any sort of service. You can't do DNS inside of the cluster. So as part of like the kubeadm bootstrap process, there is instructions to actually deploy CoreDNS pods, and they become ready the moment you deploy a CNI. Now, what's really important about the exam and CoreDNS is that you're not going to be responsible for manually deploying CoreDNS. It's impractical. I mean, if you had to deploy it manually, you're basically going to go to a completely different website outside of the realms of the Kubernetes IO docs, and that's not going to help you on the exam. They'll probably get mad at you and tell you to close that tab anyways. So what you really should be more concerned about during the exam is there are a few links here that I've thrown into this PowerPoint. I'm going to briefly touch on it on each one of these links and just give you some insight as to where they're going to really come in handy. But with respect to DNS, right, inside of a cluster, if you don't have a DNS server, you're going to have to go externally to look up like how to resolve a pod and its IP. The problem with that is it's slow. Imagine if your DNS server was, I don't know, 300-400 kilometers away, for those in the US, 200 plus miles away. And that just adds latency. So your response times for resolving names might be higher than expected, which means certain workloads won't perform as you expect it to. There might be timeouts in certain situations. So what has happened is we'll deploy CoreDNS locally and we'll allow Kubernetes to drive CoreDNS to say, there is any new pod that's deployed, well, let's just update the CoreDNS database so that we actually have an A record and a PTR record available to basically look at this pod. But we also do this for services as well. This becomes important because when we're actually accessing pods, which we normally won't be doing daily, or we won't be actually accessing pods directly or communicating with them. We'll actually communicate with services. But if DNS is not functional, then we cannot access the backend application through that service that is front-ending it. So this becomes very problematic. I'll open up this link shortly, but one thing I also need to point out is that let's say you're on the exam and DNS resolution is not working. There could be a few reasons why that might be. For example, there could be a pod that is trying to resolve information, but the pod itself might have a host file that might be misconfigured. So what you might have to do is maybe recreate the pod with a new manifest. So I guess the configuration that has an error in the host file would be wiped away. Maybe that's not the way to do it. Maybe you actually have to exec into the pod and actually make some changes to remove any sort of static configurations or static DNS entries inside of that host file. So that's something you might have to do. I'm not saying that you would for the exam, but it's something to consider. In other situations, you actually will have DNS resolution working, but for whatever reason, like, okay, internally inside of the cluster it works, but external to the cluster, it's not working. And this could be for a variety of reasons. Maybe there's a firewall that's blocking port 53, and port 53 maps to DNS. So there are like a lot of different things to consider with DNS. One thing I will say though is, like, in my experience doing this exam, I never had to go exec into the CoreDNS pods, make any sort of modifications or changes or anything like that, or get them to restart. What I had to do is make sure they actually were ready and they were actually deployed as part of my KubeADM bootstrap process. That could be the extent of what you do for CoreDNS or not. They're just recommendations. So what I'm going to do quickly is I'm actually just going to open up these links and I'll share what's inside of these documents so you have a good idea. Are there any questions while I'm opening this up and resharing my screen?
Not seeing questions. For the folks that are probably going to be watching this after the fact on YouTube, though, as long as you share those links with me, Marino, I'll put them in the notes so they can click them and follow along as they watch this on YouTube. Sound good?
Absolutely. Absolutely.
Awesome.
Okay. So this is the first link in that slide I was pointing to. I highly recommend you spend a good amount of time understanding what goes on here. It does give you a good brief primer on A records and PTR records and how we need DNS for both pods and services. But specifically when it comes to activities with respect to DNS, you're not going to be creating DNS entries or anything of that nature. What you do need to know, though, is how to resolve names, like the name of a pod in a namespace and the service that it's attached to and the cluster that it's a part of .local. And you'll have to get a sense of what that DNS name would be. So it's worthwhile looking through the cluster to understand the different names and the way to resolve them. The other link I wanted to share with you was about DNS overwrites. So my thinking behind this was, if for whatever reason you needed to overwrite CoreDNS functionality and you need to have let's say a special definition, you could do so by going into the pod. Like I said before, you might have to go exec into the pod, and this is exactly how you would do it, right? So for example, there's an Nginx pod here that's deployed in this example, and the way to exec into it is you go kubectl exec Nginx, and then you can go spit out using the cat functionality the contents of the host file. You can also go get into the shell if you wanted to, and then you can directly access the host file and make those changes if for whatever reason the question asks it. But I recommend you keep this handy because it's a little bit more definitive in how to mess around with that, just in case for whatever reason you do get a question about DNS and you have to go messing around with pods. The last one, the last link I want to share with you is one around debugging DNS resolution. This actually covers off using a test pod that has DNS utilities on it to effectively go out and run a variety of DNS tests for resolution or for name resolution. So I recommend, going to this page as well, and also reading through it and understanding how to do something very similar. This could be very handy if, for whatever reason, you have a question on there that says, the service has been created, but for whatever reason, pod A cannot resolve the service and the pod behind, the pod behind that service. So this might come in handy. I highly recommend you bookmark it. And as Ken mentioned, we'll get this over to you so you have access to these links. All right, back to the presentation. Let me just reshare my screen. Okay. All right, that's enough about CoreDNS. One last thing about CoreDNS, right? There's something called the core file. So the core file really is the root definition file for CoreDNS. Most of the time, you're never going to have to make any sort of changes with it, unless you're deciding you need to tie in some external plugins, or maybe you have some external authoritative servers that you would want to point CoreDNS towards to do some additional resolving or lookups for you. So what you can do is you can get the output of the config map for CoreDNS, understand what's in it, make the modifications, and then what you would actually have to do is reapply the pod with that updated config map. But outside of that, I highly doubt you're ever going to have to come in here and mess around with the core file. I didn't see it on any one of my exams, and in any of my, I guess, review, the core file didn't really come up in terms of what you would have to modify. I do recommend you going to look at the core file just to understand it a little bit better. Okay, this brings us to our last theoretical topic before I hop into the lab environment, and this is about Ingress. So Ingress is really about incoming requests and how best to route them and where to route them to. So I say this because you do not want to have 1,000 different DNS records for, or even like 1,000 different websites for your 1,000 pods. Like, it's not practical. Like, I'm not saying that you'll get to that state, but something to consider is you want to be able to feed in one particular host name, and then if you apply or append, let's say, a path to it, it'll take you to the specific pod that you're trying to get to, but all within the confines of the same application. So the best example I'm going to describe to you is I have a website, and that website has 2 pages, right? Page 1, which is just welcome to this website, and page 2, which is goodbye, thanks for coming to this website. So in order to get to those web pages, if I just put in the website.com in my browser, I'll get the first web page. But how do I get to that goodbye web page? I would have to append a path to it, right? So I could say, website.com /goodbye. And the moment I append that goodbye and hit enter, I am presented with another page. Now, the first page and the second page effectively just map to pods, right? So maybe this is right here. Let's say in this example, foo, I have these 2, they're very similar, they're the same pod exactly. Essentially, they're duplicates of each other, they're replicas, but they're both backed by the service. So anytime I get a request coming into foo, it's going to go to one of these pods. If I get a request coming in to go to bar, it's going to go to one of these pods over here, down here, and it'll map accordingly to the appropriate port. So what Ingress really is really about HTTP routing. Now, you probably might be very familiar with this level of routing if you played with load balancers and had to create HTTP rules inside of your load balancers to do exactly what we're going to do inside of an Ingress resource in Kubernetes. In fact, what we're going to do is we're going to build that out very quickly, and I'm going to show you how that really all comes to play here. But more specifically, the Ingress resource is there to expose your backend pods to the external world. So I see a question here. Can we use different services with Ingress? Can one path be service type node port, and path 2 be service type cluster IP? That's a great question. I'm going to have to think about that for a second. Actually, no, that's not possible, because if you have an ingress resource pointing towards a cluster IP service, it's not going to go anywhere, because if you recall earlier on, cluster IP services are not externally accessible. The node port service, however, can be there as a backend service. And in addition to that, you could probably tie in the load balancer service too as service number 2 or path number 2. One thing that I'm really interested to know why Rachel brought up this one question here. Is this something you ran into with a customer at some point or working on a project? Feel free to respond and I'll come back to it. Anyways, back into the Ingress resources and Ingress function inside of Kubernetes. Realistically, what it comes down to is making sure that you have a set of rules that will take you to the appropriate destination. Now, to actually consider an Ingress service right here, there's a few things we have to consider, right? We actually need something called an Ingress controller. So an Ingress controller is likely going to be a load balancer, because that Ingress controller is effectively effectively servicing incoming requests on behalf of the application. It's actually load balancing. So most of the time, if you're going to deploy an Ingress controller, it's probably going to be Nginx. It could even be the Envoy proxy. It could be something like Contour, or even HA proxy. There are so many other Ingress controllers out there that you can pick and choose from. In fact, if you decided you wanted to use, let's say, the Istio service mesh, even that can provide Ingress functionality. The way you would do it is a little bit different. So it's something very interesting. We'll talk about service mesh right at the end, just to kind of tie this all together and where things are going. But for the sake of Ingress resources, right, we need an Ingress controller defined and available for us. Now, on the exam, I expect an Ingress controller to be already deployed, and potentially it just doesn't work because maybe the config map name is off, or something is just wrong in the definition file for the Ingress controller. And that is why I recommend you go understand how an Ingress controller is built, because chances are it's just going to take too much time to deploy one, but you may have to troubleshoot why one is not working. Now, once you have an Ingress controller in place, you can then go in to deploy an Ingress resource. And that Ingress resource looks a lot like this. So you have a YAML file, and in fact, you can actually create, going forward, you can actually create Ingress resources using the imperative way. I actually was doing some research about Ingress, and then I actually stumbled upon, I think it was in Kubernetes 1.20, they launched this new capability where you can do a one-liner Ingress creation, and you can actually specify the service as well as the backend port and the path as well, which is super neat, especially if you're trying to quickly create an Ingress resource. Now, in this case, the actual API version path has changed. So this is I think version 1.19 and prior. So I'll go back and look at it on the documentation page just to see what this is. But one thing we need to be aware of is the kind is going to be Ingress. It's going to be called Ingress. And then we come in here and we specify the name of the Ingress. So we can call it anything we want, like Ingress resource or example Ingress. This is just the name for the actual object. Now, there's something called an annotation here. And in this case, we're using a rewrite target. Now, the reason I'm using a rewrite target here is because if I'm using an Nginx controller, it actually expects specific annotations for this to function appropriately. Now, in this case, I've actually created a rewrite target with just a random slash here, because if I'm trying to access the pod that is assigned or associated with this particular service, that pod doesn't have a backend called path name. In fact, this is the pod we're trying to access. but the way we access it is not using the pod name /pod. We actually have to access it using the pod name. So in order to avoid a 404 timeout, we'll do a rewrite, which means that, and actually, if you're looking at my screen, what this really looks like is, so if you look here, I'm going to bold it out and underline it. So if I did pod name and then /pod name, that wouldn't resolve. So in order to make it resolve, what happens is this rewrite target, which is a slash, effectively changes pod name /pod name to pod name /. That's it. And then what this effectively does for me is route me to the actual pod that I need to get to. So to simplify, right, I have a pod here. I have a pod in my cluster, and I've got an ingress assigned to it. Now, if for whatever reason my path, if I append, let's say, website.com /path name, if I didn't specify this rewrite target to just a /, to remove this path name, I would get that 404 error. But because I specified the rewrite target here to have a slash here, it just changes this pod name to nothing. It just changes this entry to nothing, allowing me to access the actual pod itself. So I bring this up because if you actually go to the documentation page and you actually go look at any of the Ingress examples or resources or anything of that nature, you actually will find that if the cluster you're using is probably going to be using an Nginx Ingress controller, and it'll probably have this annotation available. So you don't even have to change anything, but it's just something to be aware of because it doesn't make sense. A pod doesn't have a backend path. A pod is a pod. That is the backend path we're trying to get to. So it makes no sense to have path name /path name. We just want it to rewrite to nothing. All right, so that brings me to the end of the slide deck. I'm going to flip over to demo mode. Before I do, are there any questions about anything?
I just saw that Rachel said that she asked that question because a customer asked her that very question. So there you go.
So that's yeah, so that's an interesting question, but I'm willing to go with the answer that because cluster IP cannot be exposed, you can't stick a cluster IP and a node port service behind the same ingress. I mean, theoretically, you could probably apply it and pass it to the Kube API or Kubernetes API server. But if you try to route to the service that was backed by a cluster IP service, or sorry, if you try to route to the pod backed by the cluster IP service, you wouldn't get to it because cluster IP is only internally exposed. But that's something I should test out one day and see what the results are. Okay, let me pull up my website here and my terminal. So I'm going to do a dual share. Where's my terminal? Oh, there we go. Okay, can you see both of my screens?
We do. A terminal
Excellent.
and a browser. Yes.
Perfect. Perfect. Okay. There's one question. I agree. I'm still researching myself. The customer was new to Kate. Okay. Got it.
I would just recommend magnifying the text in your terminal if possible, by the way.
That's not the way I want to do it. I gotta do it this way. Actually, that's not going to work either. That's not what I want to do either. Hold on. Why is my noobness showing right now?
All good. Zoom viewers, get closer to your monitor. YouTube viewers, put this on a big TV. And then you're
I think I got it here.
Oh, okay, there you go.
There we go. Is that better?
Yes. You might have to switch focus back and forth between the windows, but you'll be right. All right, right?
Is that good now?
There you go. Yeah.
Okay, cool. All right. So today's demo is I don't know why. Okay, yeah, I'm not on a Linux box. I keep forgetting that. I'm on Windows today. Okay, so today's demo is featuring Sivo Cloud. So I know we've got maybe, I don't know, 40-ish minutes or so, so I'm hoping we can get this done rather quickly. But I chose Sivo Cloud because when I did the last session, I was actually using a bit of GKE in a self-built cluster using Kubernetes. And for what I was attempting to show, that made sense at the time. But the other thing too is the GKE environment or the Google Cloud environment I was using was tied to my VMware account, and I've since lost that. So I was thinking about how I would go about doing this, and then I realized that Siam, if you don't know Siam, he's a huge advocate in the cloud native community for all things cloud native, not just Kubernetes or anything. But he also works for Sivo, and I think he's one of their lead developer relations or developer advocates out there. But Siam put me on to Sivo Cloud and said, hey, why don't you just start practicing on Sivo? And I dug into it and I realized this is perfect because it is a purpose-built environment for those that are looking to just get started, get using Kubernetes. Like, I want Kubernetes, I want a cluster, I don't want anything else, I don't want to look at anything else. Maybe I want some compute engines for like a bastion station or something, but that's about it. And that makes sense, right? Because now you actually eliminate a lot more risk in the platform. You have two core services like Kubernetes as a service and compute as a service, and not a lot can go wrong, right? So Sivo, like for the purposes of those that are either studying or they're maybe considering building out a startup, this is definitely a great place to start. They're really good. They give you $250 of a credit to start off with, and I've been using that for the last little while. So in my case, I actually have something called the Sivo CLI installed on my Windows box here. And the Sivo CLI just makes it really easy for me to provision clusters. In fact, I have a cluster already ready to go here. But this cluster I created for the sake of my testing. I really just wanted to test a few things and make sure that this whole session would go pretty well. But what I want to do is I just want to show you something here, right? So to get started with Sivo is pretty easy. The CLI, literally, you just download it based off of the operating system you're using. Once you install it, you just go grab an API key off of your account, which is somewhere in here. Once you assign that API key, it even tells you the exact command you need to use. That API key is persistent through reboots. And at that point, you can you're authenticated into the cloud. So if I did a Sivo Kubernetes list, it lists my Kubernetes clusters right there. So this is the CKNet02 cluster that I created previously, and it's currently active. So what we're going to do is we're just going to create one more. We're going to call it CKNet3. So Sivo Kubernetes create, and I'm just going to use the help command because I can't remember everything. Yeah, there's one thing I had to do to open all ports. Yeah, okay, here we go. So create firewall all. Okay, got it. So Sivo Kubernetes create cluster name, and then we're going to do a new firewall and then all. Okay, so Sivo Kubernetes create, and the cluster name is going to be CKNet03. Create firewall all, and let's see what happens. Okay, looks like that's good. So the reason I had to enable the firewall all and open up all ports is not because I want to let a lot of malicious actors into my cluster. That's the last thing I'd want. It's actually because I'm exposing a service and I need to be able to access it on a given port. Now I could have narrowed down the open ports to the range that I would be accessing this from. But I figured, you know what, let's just open it wide and not have to deal with any sort of port related issues or have to troubleshoot why the firewall is not working or something like that. But as you can see here, like, look, the cluster is building, it's doing the bootstrap, it'll go out, provision compute nodes, and then it'll run through its process. Now, I probably am guessing that a lot of you are wondering why you're seeing K3s here. K3s is a variant of Kubernetes. It's I would say a slimmer or a slimmed down version of Kubernetes. It operates in the exact same manner, follows the same set of principles. It just uses lighter weight components based off of other research, based off of research that has been done in the cloud native space. And in my opinion, I mean, it's perfect. I mean, it does exactly what it needs to. It operates no different than a regular Kubernetes cluster. It's just K3's back. That's it. Now, the cluster itself, as it's deployed, it's going to be a 3-node cluster. It will have access to a load balancer. So when I call on the service, it'll spin it up. It'll make it accessible, and it will be good to go. In addition to that, you know, if I wanted to, I had access to marketplace appliances. So if I decided to manually deploy this through the, let's say through my UI here, I would have the option to go in and select this. Now I could probably do this through the same, I guess, set of flags here. However, that'd probably take too much time. And this is really not about Sivo. This is more about the CKA. But I just wanted to make sure that you were all aware of a platform that allowed you to just, you know, test out everything. So just came in to verify all ports are open. So we're all good to go. And we just need to do a few more things. So let's do a Sivo Kubernetes list just to verify that the cluster is up in there. Perfect. And what we're also going to do is we're going to do a Sivo Kubernetes config. I think that, hold on. What was the command? Yeah, it was config Sivo Kubernetes config / or the name is cknet03 save and merge. So what this actually is doing is it's actually going to go pull the kube config file from the cluster, download it, and merge it into your already existing kube config. Now that is very cool because a lot of other providers I've seen will just basically give you a kube config, and then you're the one that's going to be responsible for merging that kube config with your existing kube config. Have fun with that. It's not impossible. It just becomes a little bit more harder to do, mainly because like you're looking at a lot of details and it becomes quite blinding, I would say, because you just see a lot of details and it can get confusing and whatnot. So this function is very cool. Like, okay, it's merged. It's good to go. All I need to do is do a kubectl config use -context ck03. And if I do a kubectl get nodes, it will tell me that my nodes are right there. So just to verify some things here, we're just going to get and check the IPs of these nodes. So we've got internal IPs and external IPs, and looks like we're good to go. Okay, so what we're going to do is we're actually going to verify something here. So Kubernetes service here, and it's of type cluster IP. If I did a kubectl get svc-a, it's going to enumerate all the different Kubernetes services inside the cluster in various namespaces. But the one I really want you to pay attention to is this one, kubeDNS, which is actually CoreDNS. But in the case of, I think in the case of K3s, it might be some other DNS. That's okay, it doesn't really matter. It still operates the same way. But notice that it's cluster IP because we only need to access DNS internally. Notice that there is another service here called Trafic. It's using the load balancer service, and there is an external IP for that. I need to go back and check what that's used for, but I think it's just actively providing the load balancing functionality because inside of, oh, actually, no, it's not. I think it's doing something else, but that's fine. It's going to be our ingress resource in actuality, or I should really say it's going to be our ingress controller that's going to service our ingress resource. We're actually going to go out and create an ingress resource right now and see that live on the web page. So I'm going to just minimize this over to the side here. And what I'm going to do is we're going to start here. So what we want to do first is we actually want to create a deployment. The deployment, we can call it anything, but I'm just going to make it super simple, and I'm going to use an imperative approach. So kubectl create deployment web, and I'm just going to use an image from GCR, one that I know that is working. Hello-app 1.0. All right, so the deployment was created. Let's check and see if the pods are good. All right, we're good to go. Next, we're gonna one-liner expose this. So one thing to be aware of is if you have to create a service inside of the exam, it's easier to create the service using one line and then go back and edit it versus going to get the YAML. So I'm going to go in and expose the service, or expose the deployment, I should say. And the way I do that is kubectl expose deployment, the name of the deployment, which was web. The type that I'm going to assign is node port. And I'm going to come back in and change this load balancer very shortly. Node port. And I'm going to give it a port of 8080. Hit enter, and I'm going to run kubectl get SVC. And there we go. So I could technically access this web service on the node port on this particular port here. But in order to do so, I would need to know the external IP. So if we up arrow a bit or wide, I can take any one of these external IPs, which they all happen to be the same. Which I think is because of the load balancer, but that's fine. So I can take one of these IPs and we can see if it resolves, just to see if it resolves. 32681. Okay, so it resolved. And that's the app. I don't know if you can see it, but hello world, and it's actually resolving from the web pod. So we know that works. Great. Now what we want to do is we actually want to create the ingress resource. So the ingress resource, actually, I'll show you something interesting. The task that I'm following through with is right here. So I'm actually using this task right here so we can follow along together if you're curious. But I've gone ahead, exposed the pod. I use node port. I'm going to go back in and change that to load balancer because we want to be able to access it from the load balancer. And we can see that the service has been created, and then we can go back and access it on whatever we want to. So we're going to go in and create an ingress resource. Now, what's interesting is you could do it the YAML way, right? Like you can literally, I'm pretty sure if they ask you to create an ingress resource, you can come right to this example and just copy and paste this exact example. Like you could probably use this one, change maybe the name, and then maybe the name of the service that you're using, and you're probably done. Maybe you have to change something else. And that's all you have to do for your ingress resource. Now, I'm not going to paste this into a notepad right now and mess around with that. I'm lucky enough that they left an example for me here, so I don't have to really go in and do anything crazy and create this file all over again. So we'll go in here and I'll just run the command, and it's created my ingress. So if I do a kubectl get ingress, there it is right now. So in order to access the application, I just need to go to this particular website, this address, and I should be able to hit it. Now, one thing I need to point out though is if you look here, right, I have a path that has nothing and I have a rewrite target that says $1, which means we're just going to the first version. But what's really interesting is we're just going to a default path which is essentially the only page that exists here. If I add another path, what we have to be aware of is how do we ensure we add a default backend so that it'll always go to one particular destination and versus going nowhere. So there's actually something called a default backend, which you can see actually in this example, default backend. And you come in here and you add that in under your spec, which basically says, make sure that you specify a default backend to go to that destination should no other destination be available at any given time. That's easy enough to do. You don't have to really worry too much about, where's my example? There we go. Okay. So where were we? Okay, we've got our Ingress resource created. We have our service created. We're going to go in and we're going to modify the Ingress resource. kubectl edit Ingress example. Oh, actually, no, we're not going to modify the Ingress resource. We're going to modify the service. We're going to edit service web. And one thing I need to do is I actually need to add one more window here. Okay. Can you see the little notepad that just showed up?
Yes, we can.
Okay. So the moment I ran kubectl edit SVC web, the notepad just showed up. Now, one thing to be aware of is because I'm on Windows, I actually had to use command prompt under administrator mode because any changes I make here won't get applied. So if I did it with any other account. So I'm using administrator mode. This guarantees my saves and I should be good to go. Now, notice in this node port right here, notice in the service right here, it's set to node port. So all I need to do is just, delete this, change this to load balancer. And if I want, I can leave everything else blank. Actually, I could probably just come in and delete this right here. And I hit Control S, save it, close the window, and then the service has been edited. So now if I go back into the service again, it's now a load balancer service. So if you look up here, right, it was node port. I ran the command edit SVC web. I changed the command to load balancer. And this is the external IP I'm going to be using on this port to access that particular application. Now, there's one thing additional I need to do is I actually need to edit my local host file. So the reason why I need to edit my local host file is because I haven't registered this address with DNS anywhere. So let me go ahead and do that. In fact, I can remember edit Windows host file. Okay, so maybe I just maybe I do this. That didn't work. So do notepad. Okay, you can't see it now, but I'm gonna share my host file too, which you all should see now. Right, Ken?
What's that? Oh yeah, we can see it.
Okay, so I had an entry in here before, but I'm just going to delete that and I'm going to change it to 212.247.202. Let's save that, close that off. So now, if I go to the website helloworld.info, oh, shouldn't work. There we go. Okay. So the moment I go to helloworld.info, it resolves to this website right here. So the very last thing we're going to do is we're also going to create a second deployment so that we actually have access to a second website or the second page of that website. So I'm just going to copy this to speed things up. Basically the exact same process. The only difference is the version is app number 2. And then we're going to expose it. But this time we're going to make it easy and we're going to just use the load balancer type. So I'm going to go expose deployment, web 2, it's 8080, equals load balancer. Done. So if I do a kubectl get svc, okay, so it's just waiting for the load balancer IP to get issued, and that's okay. We'll wait for it. It'll do its thing. In the meantime, we have to do one last thing in order to be able to route accordingly to the same inbound address. And what that happens to be is I just need to modify my ingress resource. So we actually go back and edit the ingress. So ingress, example ingress. And the moment I do so, a new notepad will open up, which y'all can't see yet, but you should be able to see it now. And inside of this notepad, right, all I'm really doing is hitting enter and adding the second path. And this is what I hate about the indentation, because it always gets a little jacked up there, but okay. So here's the second path. I know if you look at this first backend or this first backend path right here, you'll see that it's a little bit misordered. That's okay. That's fine. It doesn't matter if you start the array and then all of a sudden you have backend and then path type here, and then over here you have path and path type right afterwards, and then the backend. It all reads the same way. Kubernetes will process this just fine without any issue or without any sort of concern. So what's interesting is the moment I add this into the ingress, this web 2 pod now also becomes accessible through the same IP, through the same host name. But the difference is I have to append /v2 in order to get to it. So I'm going to save it. I'm going to close off. And if I just run a kubectl get ingress just to verify that the ingress is there. Okay, so it's still good. I'm going to go over to my website, right? So I'm here in my website, hitting refresh. All I need to do is append v2, and I should get my version 2 of the application. If I remove it and change it to v1, I get version 1. If I remove the backend path altogether, I go default to version 1. So what I have effectively done is created HTTP routing rules to get to each one of these backend destinations appropriately. I basically said, this pod is a part of this service called web. This other pod is a part of this other service called web 2. You both exist, but you're both part of a rule set. And that rule set will only be actioned should you be going to each one of these destinations according to the URI that you're coming in from. Now, that is effectively what you need to know for Ingress. Once you can successfully do something like this in a lab environment, you should actually have no problems at all being able to be successful on the exam. Okay. Awesome. Okay, so there was one more thing I was going to show you. Wait, was it in here? Oh, no, shit. Okay. So one thing I wanted to point out is on the exam itself, when you're, I guess, prepping or when you're going through each one of the clusters to run through the activities, it always helps to verify that your ingress resource or your ingress controller has been deployed. It would actually come up as a different name. It would have like something with the name ingress in it or the name web nginx or something of that nature. If the ingress controller is not working for whatever reason, the question would probably state that there's a problem with the way we're accessing the ingress resource itself or the backends. go investigate. And at that point, you might be troubleshooting the ingress itself, or you might be troubleshooting why the controller is not functioning. And it could just be a config map issue or something of the like. I think that's all I had to show in terms of the lab environment, or in terms of what I wanted to do. The only other thing I would say is get really good with doing imperative commands, because if you aren't good with imperative commands, it's going to take a lot of time to go dig through YAML, find the right examples, and then be able to apply that during the exam. And then I have to deal with indentation. Indentation, for that matter, is a nightmare, because if you get it wrong, it's going to keep giving you an error until you actually find the right indentation for that whatever line you have. One thing I'm going to do is I'm just going to go back to my my browser here. So there are a few links I think I pointed out. This one is definitely one you want to have for your CKA exam. Here's another one as a reference. This is the specific Ingress page, so you definitely want to have it. You also want to keep this example. Sorry, I'll come back to this in a second. You actually want to keep this example here handy, how to set up an Ingress resource. You would be surprised at the number of different questions that you get, which basically, they just want you to go to the documentation page, pull out the example, change maybe a name or two, and then drop it in. That is probably the fastest way you're going to get a question completed. If for whatever reason documentation is not working for you, or copy paste doesn't work for you, that's where the imperative commands come in. The one-liners are very powerful. There was another link that I wanted to show you here. Where was it? Ingress. Okay. Okay, here we go. So I stumbled upon this not too long ago. So as of, I think, 1.20, maybe, you can actually do an imperative one-line creation of your Ingress resource. So you're creating an Ingress, the name is going to be called simple, and the HTTP rule that you have maps to this host, to this service on this port. And basically, this is just a label that's assigned to it. So basically, the Ingress is going to map to that service, and then will effectively route to this particular backend, foo.com/var, if anyone is hitting it on port 8080. That is the quickest way to do it if you don't want to go to the docs page to actually procure a YAML file. I haven't played with all of this. I do recommend you come in here and test this out for yourself so you get familiar with it. This website right here, this link right here, is completely accessible from the Kubernetes docs page and is also available to be used during the exam. So have it open. We don't need this. We don't need this. I've already covered this. I've already covered this, and I've already covered this. So I think that's really good in terms of links that you should have handy. Yeah, that's really it with respect to CoreDNS, with respect to Ingress services, and other aspects of networking for the exam. The very last thing I'm just going to cover off is Istio, and I'm just really going to spend like maybe a minute or two on it. So Istio is a technology called service mesh. Service mesh meant to, or is aiming to solve the problems of like a multi-cluster setup where you have multiple Kubernetes clusters. It's meant to solve the locality routing issue where maybe you have an application or a set of applications that are spread out all doing the same things, and maybe you need some geo routing to efficiently get access to that application. Maybe you need to provide security between your services, and by doing so, you can either do one of two things. You can either provide identity awareness, so you know and you can authorize services who communicate with other services, or you can also provide in-flight encryption between services using something called MTLS. Now, why I'm bringing this up is because I could foresee in maybe a future iteration of the CKA exam where service mesh is going to be talked about. Now, what's interesting is on the CKS exam, there is actually a section on certificates and MTLS. MTLS is a function of service mesh. The other things you'll also see in a service mesh are things like observability. So you'll see metrics. You'll have the ability to do tracing. You have the ability to do traffic routing. And when I mean traffic routing, I'm referring to Ingress, because Istio, the Istio service mesh is effectively also an Ingress resource or an Ingress controller as well. It's just that the way you define Ingress resources are a little bit different, and that's okay. It's still providing the same level of functionality. I bring this up because it's something to be aware of. You're not going to stop at just Kubernetes. You're definitely going to expand and learn a lot more in the cloud native space, but it's a technology that you're likely going to run into. It's starting to make waves in the industry, and it's just something that from a networking standpoint is very valuable. It's like the next generation approach to providing secure, observable communication between various endpoints at scale. But that's service mesh. And with that, I would like to thank you all for your time tonight. And that pretty much wraps up my session today.
Excellent work. Thanks very much, Marino. Appreciate you being part of the series. Biggest thing I learned was over the course of the series, and including tonight's session, everything you need to know seems to be in the docs. Everybody keeps referring back to the docs. So everybody bookmark the Kubernetes docs, because that's the place to be. It's very popular.
It is.
Thanks again, and thanks everybody for joining us tonight. We're going to continue next Wednesday with, I believe it's actually episode 9. We're skipping ahead a few, but also episode 8 is being recorded in EMEA next Wednesday. This episode, if you're viewing it live and want to go back and view it, will be up on YouTube within usually about 48 hours. But until then, we'll see you next time. Thanks, everybody.
Thank you.